Hey folks, how's your GSW going on till now? I know you have seen Ritvi's stream and it was amazing. I was there too. I really loved how she explains hardware and it's really interesting and I wished like it never ended actually. And let me welcome you all to our second stream of bash scripting. So I'm gonna welcome it the bash way today. No graphics, sorry. Welcome to Global Hack Week January and welcome to part 2 of Bash Scripting. And if you have not attended the part 1 yesterday, so I'm going to give a quick recap of what we did and I'll basically explain something like what is Bash and how scripts work and then we will dive deep into it. So today we will be doing a lot more practical check-in button. Oh, you need the check-in link or let me do that once again. It's in the chat now. Okay, yeah. First things first, please do check in. It's here. And to go all in, I did not use my Mac today, and I am. It shows registered but not checked in. Um, I'm not sure. Think there is some time problem because when I tried adding my session to my calendar, uh, it showed like my session is at 11:30 p.m. till 1:30 a.m. and that was not right. 1 p.m. to 3 p.m. Yeah, that's wrong, I think, because it's right after Ritvi's session, and if you convert the time, which is like 3 a.m. something to 3 a.m. ET to IST, it shows this time right now. So it is kind of wrong, I guess, but I'm sure my session is now. So yeah, don't worry. I'll convey that to Mary or someone from the GSW team, and they'll add your points to all. Okay. Hope this makes clear. There is some time differences in between, and I think that's a mistake from their side. But you are at the right session and the right time. Alrighty. So if you are all ready with your terminals open and all ready with energy and some hydration, then let's get started. So, I will give you all a quick recap of what went yesterday. So, yesterday we learned about what is Bash and we got comfortable with it. Like, we discovered a lot of commands which we can use daily, like nano, cat, touch, how to make directories, how to delete them, and some dangerous commands like rm star, which we should not use. So yeah, I will give you a quick recap of what is Bash. If this is your first session, you can still catch up. So, Bash is a shell that runs in the Linux terminal, and Bash is not only the shell that users can choose, but it's the one most commonly shipped with Linux distributions, as you all can see. Not only Linux, but even like Mac OS, or you can see Windows, you can see everywhere. So, Bash is like basically shipped with Linux first, and it is like a universal way to interact with computer, and the shell serves as a command line interpreter, which means it takes readable commands and passes them to the Linux kernel, and then Linux kernel says, "Hey, I got a command, I'm going to execute it." And then Linux kernel sends instructions directly to the hardware. And there you go. So Bash doesn't just run commands and other programs, it has its own programming language too. So that is in your bash script. And now, what is bash script actually? So we will be looking that too. So bash script does not care where the commands it runs come from. So it can just take the inputs. Let's say I just put something in here, it can take anything I want, and it wouldn't care. Uh, and it can get its own instructions from a special kind of text file called bash shell script. So shell scripts can be used to automate common tasks, and they make accomplishing complex computing tasks possible. So like, let's say you are opening your terminal and writing commands over commands, but this can be like shortened using bash shell script. uh, with just one click of a mouse, or with just one command, you can do the work of 3 to 5 commands or 6 commands at a go. And you can also get shell scripts to run at startup, so special parameters can be set at certain programs that can be opened automatically. So like let's say I am opening my computer and I don't want to go through all the boring process. Like let's say I want to open my Chrome, I want to open my VS Code, I want to open some apps all at one time, but I have to do it right after, like when I open it and I click on one single app, one single folder, and they are opening one by one. I don't want to do that. I just want to like open my laptop. Ooh, all apps open. That's good. So we can do that with Bash scripts, and they can range from one line to all the way to a full fledged programs. So yeah, you can write your own Bash shell scripts. There are only few hard and fast rules. So once you learn them, you can feel free to experiment and come up with new ways. So just as I said, I want to open few apps. I want to run some commands. Let's say I want to update, keep checking for updates, but I don't want to like type in all the commands in the terminal. I can do that. Um, so Bash is very flexible, and there are many ways to do the same thing. You should not let anyone tell you're doing it wrong. And if your script run and sorry, let your scripts run, and you can let them do what they need to, because that doesn't go wrong when you are like not typing it. So we all have to start somewhere. So this is the place you can get started with Bash scripts. You don't need to like have a lot of knowledge, but I'm gonna assume that uh, you all were there in the last session where I just told how to navigate files, how to edit text files using Nano, just like I'm doing here. We can open up a text file. See, I'm gonna exit. I'm gonna say no, and you can just do Nano and some text file name. Let's say file one, and you can see that file 1 is opened now. You can edit it and something, and you can save it. You can do Control X, you can say yes and enter. That file will be saved, and you can do ls, and now you can see that you have file 1 here. All right, so this is all the basic stuff which we did yesterday, and today we are going to look into more complex stuff. So let's get started. So for the bash script, you will need to use a plain text editor to write your own scripts. So every Linux distribution has one text editor which can run in the terminal. So we can do nano, and there we go. We opened our text editor, and a basic script looks something like this. So we can do this hashtag bin slash bash. So this is how it looks, and you can write any comments using hashtags. All right. And the first line, which you see hashtag bin bash, the first line that is called shebang or hashbang. So it tells the system that this is a script and that it needs to use the bash shell to run the following commands. And any line that starts with hashtag is treated as a comment and will not be considered as executable code by shell. So you can also place a hashtag after a command to write a comment, what you're telling what you're doing. Okay. So now we will let me close this and let's clear up. Is Nano only for Linux? It works everywhere. I mean, I have seen it in Mac OS too. I'm sure it'll be in Windows or somewhere else you can use. Okay. So in Linux, since it is a unique Unix-like system, it will run sh, and you don't need to write sh if you are doing it for Linux. But if you are doing it for something else, then yeah, that run on all kinds of systems. So we are concentrating on running scripts that are going to run on your own system today. So it won't be based on Linux or Windows or Mac OS. This can run into anywhere. So let's jump into a terminal and I will show you how to do this instead of just looking at text. So we go with Nano and let's type in Nano. Never mind, I have Windows subsystem for Linux. Cool. So it works. How do I exit Nano? Control X. You can see when you do Nano, you can find the Control X too. So I'm gonna name it first dot sh. So the main thing about naming your script is that you will have a unique name, and you don't want your name to name your script after something that is already on your command line, like bash src or something like that. So you don't want to do it. And uh, this is something like you can name anything. Let's say I want to do it gsw.sh. I can do this too. And it you can keep it simple, because if you want to type it again and again, you don't want a whole long name to go there. So you can do this. And we have our gsw.sh. Now we will say, since this is, we want it to be bash, so we will do, oops, bin slash bash. Oh, okay. And now this will know that it's a bash script. And now let's try. Since we all know that every programming language we start, there is one hello world program. So we will be doing the same here. So I will write a comment which says this is uh, um, yeah, hello world program. You see, that's the quality of a good text editor. It just looks up and say, like, highlights the word everywhere. So you want to put up a comment that basically kind of tells what your script is doing, because if you forget to put comments and you write commands there, you might forget in the future what that command does or what that script does, and might execute some script which you do not want it to. So yeah, let's start with the commands. So you could just put commands in and you don't have to put comments. But it's a really good idea if you start commenting and you get a detailed understanding of what you're doing right now. Okay, so we will start with a simple echo. Echo basically prints what we are typing in here. Oops, I did a mistake. Okay. And we will say that this prints hello world. Okay. So all we have to do now is save it, and so in Nano it's control X and it will ask you to save buffer. We will say yes and file name yes, and now it's done. Now you should have your file name there. So let's try ls, and we can see that there is gsw.sh, and we can try doing ls l, and it gives gsw.sh as read write and read. It does not have execute, so we have to add the execute permission. So just as I explained yesterday, chmod does that. So chmod plus x ghw.sh lsl. Oops. And now we can see that it has x in front of it, so it is executable. All right. Now since it is executable, it shows in a different color, so it is green now. And we will do chmod. Also we can do 755 since it's executable. As I told you yesterday, 7 gives us executions, um, write permissions and read permissions, and 55 for, oh sorry, already wrote 55. So 55 is for read write permissions for others. So this is actually my preferred method, since it gives the user all the permissions first, and then it gives the group some permissions, and it gives some other permissions to everyone. So we will execute it. You can make it executable or not executable for others. What was the command to make it executable? Acha, that is chmod plus x. I can show it here. This one. And your file name. And yesterday we thought the numbers. So 4 stands for read permissions, 2 stands for write permissions, and 1 stands for execution permissions. And you can do plus x plus r plus w, and the alternative is chmod 7 3 numbers, so it gives read permissions for read write execution permissions for the user. 5 if you just want to give them execution and reading permissions or anything you would like to. And now do lsl. Now you can see that the user has permissions. Now we will do we will try to execute this file dot slash. Can we automate tasks with bash scripting? Yes, you can, and we will look at it in like few minutes. and let's try to execute it. Mm, okay, now we did it. Since it is already in our home folder, we can do just dot slash gsw dot sh, and since we had an echo script inside it, it just printed hello world. All right. I joined late. That's all right because I am just starting out now, and we executed our first hello world program. Yay. So I can give you a quick recap of what we did. So basically, what I did is first we opened up a file using Nano. So Nano is a text editor, and we gave them a file name called gsw.sh, and we did ls to see if it's really there, and it's there. So later we did ls.l to see what permissions it has, and it did not have execution permissions. So we have to add execution permissions, right? So we did this, change chmod plus x to give them permissions and the file name. So x gives you execution permissions, and we did lsl, and the alternative method is writing the numbers. 7 gives you all the permissions for users, so we wrote 7. 5 gives read and execution permissions to others, so like everyone and the group users get execution and reading permissions for the script, and we did that. And when we did lsl to see what permissions it had, uh, we got read write execution and execution read and execution permissions for everyone. So we did that, and then we executed it using dot slash gsw.sh. Since it's already in home folder, we need not have to change it. And gsw.sh contains echo hello world. So what echo hello world does is, echo is a command that prints stuff. If you write anything, let's say hello world, hello computers, hello gsw, anything, it will just print out, and when we executed, we got hello world. So that's the recap of what we did till now. All right. Now testing the script. When you remove x, sorry, uh, nope, nope. Yeah. So when you have the script and you want to test it, you might run into errors, and you might want to test it. So just when you run it, what's gonna happen that it's gonna tell you what the error is, but sometimes it gets a little bit confusing, and you would like to see what the script is actually doing, because most of the commands don't automatically just print what they are doing out to the screen, unless like just like we did here echo. But other commands might not do. Let's say you wrote sudo apt update or something, you did git add or something like that, and you have a whole file of commands which you have to execute. Are you late? You're not. I'm just getting started. Well, welcome. We just wrote our first hello world file, hello world script, not file. Okay. And so basically this is what we did. Nano. So this is the script which we did, right? And since I opened it up again, so not all the commands will print anything what the commands will do. and we don't know what's going on. So to fix that, what you can do is you can run uh, you can put tracing here. So you can save your script, and we will try if that works. Let me see. Wait. And if we do this dot x, and we will save our script, and let's see what this does. And now I will run again. Oops. See, now it prints what the command actually is. So we don't have to open up our file. What we did is just we added plus x to the bin bash script, and it traced out. Okay, and it will print out the command. And now we can do again, and we can just remove it. And now it will be gone too. And don't forget to remove the x when you are done fixing the problem. So if you keep on keep the x on, it will print out all the commands, and you don't want everything on your screen, right? So you can remove it later when you have done fixing your errors and see what's going on. And now where to put your scripts, you will want to move your scripts somewhere uh, with path statement, so you can run it like any other installed program on your system. And there are two preferred places for scripts. So basically what we are going to do is we will move our script, and now we will see that how to remove. Okay, you want to remove the x. So see, we again open up the nano using nano, we again open up the ghw.sh file, and you might see there is some x here. This is what you have, right? So you can just go on backspace and click Control X and save modified buffer, yes. And file name to write, it's still gonna be GSW. So we gonna just do enter, and it's done. So if you execute it now, you will just see hello world, and you won't see echo hello world. So there are two preferred places for the scripts you write to be placed, and any other executable handles by sorry you can store it like in place where you have other programs, any executable programs, or in places where you are currently now in, like your home folder. So where you can store is like, it should be something like this: home username slash bin. This is a great way to store, or user slash local slash bin. These two places are preferred. So Ubuntu and many other Linux distributions will find that you have created a directory in your home directory called bin, and you have stored your files and scripts there. So it will automatically fetch it up for you, and you don't have to write your whole path when you are executing your script. So yeah, we will do this now. Let me go back. And now cd, sorry, we will do ls and We see that we have our gsw.sh here. Now what we will do is we will create a directory, and we will see that the particular little directory, and it finds it will add the path there. So we are in our home folder right now, and let's see echo path. Now this gave me all the path of the bin. So till bin, we can see user local slash sbin slash user and etc etc. So system looks for this, and I will show you where it looks. So if we are going to do cat dot bash rc, now you can see where the bash rc is there. And let's see if we can find where the path of the bash rc is, and we can simply get our other scripts there too. So we can do also check cat profile. Mm, so here you can see set path. So this includes user's private bin if it exists. So this is the path, that's how it works. So it went through all of that to show you that this is where it is stored. So like path is home bin slash s path, and this is the user's private bin. So this is what it does, and the profile it grabs for you and sees if it exists, that path, if the user's private path exists, and it's supposed to run this a couple of distributions, like MX Linux or MX Mint or any Linux distribution. So you can see that this path variables are in Linux mostly. You might not find it in Mac, as I did not. And now we will do clear, just to clear out the screen. And now we will see if we can wait. We have to set the path to home slash bin, and we will do that now. This is the path. I'm gonna put it here so I can copy it easily. Equals to $home slash bin, and we will oops. So this is the path we have to set, and we need to restart the system to make this take effect, since like it needs to reload. And then once we have done this, uh, it will directly see from the bin and execute it. But we are not going to do this now since it's already in my home folder. So you can do it though later. And I will show you something else now. So on most of the keyboards, you can use backslash, since it does not use the character like enter. So we are using the backslash here, and then we will see if we can install something else. Oops. MC. And we can save this. We are trying to see if we can get something else installed with this, so that's why we are trying to do it. Let's see if we can. Now let's see if it does. So basically it can install everything along with like any packages. So you can just write a script, and then you can get it inside like whatever you want to install. Let's say you want to install some browser or anything at one time, and you don't want to execute each and every command, then you can do that. And you can just press install, like just execute it, and it will show you like all the commands at once, and there you go, it will get installed. And we can just control. Okay, we can stop this process too. We currently don't need it, so I'm gonna stop. And we will now see some other commands which we can use. Let me open up my terminal real quick. Okay. So now we will try to see how we can use some functions. So we can see redirection, variables, arguments, and tests, and if statements and functions. So you all know that in normal programming languages we have if statements, we use arguments, we use tests. So we are going to look into all of that. So redirection in Linux is when executing a command, you can change the standard input output devices. So the basic workflow of any Linux command is that it takes an input and gives an output, right? So std in, here I can type it out, std out, stderr, and redirection. So we are going to look into these. So standard input std in is the device, so the keyboard of your device, and the standard output std out is the screen of the device. Okay, and standard error is the error message. So with redirection, the above standard input and output can be changed, and you can use pipes to take the input from one program and send it to another. Okay, for example, we will be writing something here, ls miss l slash documents, and it says 0. Now ls, oops, now since this has very less information, so I will try to get something else, ls slash l, which folder do I have? I have, let's try downloads. Downloads has a lot of stuff. Okay, now this has a lot of stuff here. So now what we can do is we can change the pipeline, and since it's running out of screen, let's try and get into something else. Downloads slash less. We explored less command yesterday, right? So now you want all of this output to go somewhere else. We can do ls minus l. Since now the screen is showing that all of the output, we can add all of this output into something else. Let's do lsl slash documents, and we can add it to a text file. using this command ls out dot txt. Oh, I forgot this. And now we can do ls and now you can see that when we executed this command, right, ls down to downloads, we what we did is we just did told that we don't want the output on the screen like this above. We want it in ls out.txt, and now all the output is gone into this txt file. And now we will see if it's really there, and we can try using ls out.txt. Now you can see all of that is inside this text folder, right? And we can clear it up. So this is the way you can just use any text file to bring out all the output. And now you can change the text file to something slash a folder, let's say. Now we want it to go somewhere else. Now you don't get any output on the screen, but you can see that it's gone into some folders called dev slash null, and you don't care about its output, so you don't want it to go. Let's say you go into a system email which will end in the root, and users end up in the root, so they don't want to see any unwanted stuff. So we can just use this command to send all of the output to somewhere else where you do not want it to be seen. You can send output files to anywhere. Let's say you can send it to some folders, you can send it to some files using lsl some directory to using this greater sign to some text file, or you can also do you can also send it to some folder, and it will be gone. So you you can use all of this, and then you can also send the output to stdrr. So you can do echo script error. This is error message. You can also do this. So when you don't want it to send it to some text folder or some text file, you can just send it to error message using stdrr using this command. Okay, we did this. Wait. and we can do echo. You can see that it said error. Now let's try do this. And there are also variables in bash scripting. So now since you know how to send some output to one place to other rather than the screen and keyboard, now we can see that there are variables, and we will start trying out some variables. So variable is a character string which we assign a value, and a value assigned could be a number, a text, a file name, or a device, or any other type of data. So a variable is nothing more than a pointer to the actual data. So the shell enables you to create, assign, and delete variables. And you can also list shell variables with the env command. So we can create a variable by using, let's say, give it some var equals to data, and a variable is created. It's that simple. And you can read a variable using echo. So you can do echo var. This is something like path variable. So if you have seen path variables, it goes with a dollar sign, and you have capital letters. When you do echo path, it shows you all the path of your screen. Like let's say, let me do this echo path, and this is a variable. Since all of this, when you do echo, it reads it out, like user, local, bin, all of this can be called as a variable. So we can also read the variable which we just declared right now, which is var equal to data. So echo dollar sign var, and it will say data, since that's what I declared here, var equal to data. And we can also remove the variables. So before removing the variables, I'm going to show how we can load up all these variables using env. So we see that first we typed up env, and it gave us a whole bunch of information here. So we scroll down and we see that this is in user bin slash env, everything in here. And now we can set variables easily using a equals to b echo a. And now we can remove the variable. Let's say I said a equals to b, but I can do unset a, and it unset A. Now we can see if we try echo A, it's still giving me B. Let's see. Now echo A. Okay. If you do unset, you don't have to use the dollar sign and you can just use A. So unset A, if you want to unassign any variable, since A equals to B, we did echo dollar sign A, it gave us B. And now if we want to unset, we don't have to use the dollar sign, we can just do unset A. And when we do echo A to see if there is some variable assigned, we see no variable is assigned now and it's empty, right? Now you know how to assign variables and you know how to unassign variables. Now we are going to look into how to do arguments. So arguments, if any input a user adds after the command is placed in a special variable called arguments. Each argument is defined by a space between them. So if we had a mythical command called twiddle, or if we had a command called mm, install live, and we launched it with a command like this. So install live file1, file2, file3, and what we typed would be into the shell variables would be like something we will be assigning some variable, let's say 0, and we are giving it some install live, and we are also assigning some files to it. Since we have not created it, it won't recognize and say it has no such file or directory, but that's what we will do. We will assign all of that right now. And if you would type install live help, it should give you all the help like dollar sign equals to twiddle, and it should give you dollar sign equals to file1, file2, or anything. We can assign the help commands to it. So yeah, we can do that. Now let's try and use variables. Let's try test A equals to B. Oops. Okay, first we will do A equals to B again, and now we will do test A equals to B. Now we will do test A equals to B again, and then and echo yep. So what it does is instead of just saying like executing without any output, we can say test A, if test A equals to B. If this is true, since we assigned A equals to B here, and if this is true, it will show us yep. And it did show us yep. And let's try if A equals to B. It's already there. And let's try, let's remove B and make it C, and let's see what's the output. It does not give any output. So we can also add some other arguments like here echo. This is like otherwise if A equals to B, give yep. If A not equals to B, give something else. Let's say nope. And it said no, since A is not equals to B. So this is simple testing which you can do. And you can also try to B, and it still gave yep. Also, you can use this for any testing any command, like seeing if a file is present or not. Let's say test bash rc and echo echo. If bash rc is there, we can print bash rc is here. If bash rc is not present in your system, you can print bash rc is not here. You can do for anything like dbkg, or for installations too, like qw fif nepg sudo. Oops, I wrote equal to. YYQ FFNEPG MPEG. Oops. I'm making some typos. Please forgive me. And what this will do is, this will say like, first do this command, then if there is ffmpeg present, you can just check, and if not present, you have to install. So let's try and like execute. What happens is, it just first executed this command, the first one, and it sees if the grep is present, then it does this. If it's not present, it will install. Since it's already present, it did not install anything and it just executed. Now we have seen variables testing, and we have seen arguments. You can also use if commands. So if statements like normal programs, you can do if test something, then run command. If the answer is yes, the command will run. If the answer is no, the command won't run. So you can do that too. So you can do something like this: if test something, and then it gave me automatical insert. So we can do run command if yes, else run this command if answer is no. So what we did is, we wrote an if statement. If this is present, let's say uh, if a web browser is present or something is present, then run this command. Let's say updation. If a browser is present, we run update Brave. Then if not, we can do else, and we can say run this command, install Brave. If there is If the browser is not present, it will install, and if the browser is present, it will just update, right? So we can exit. So this is all if commands, and you can use something like this too, like two lines here, and then you can say like this for testing variables or testing commands. You can do this. If not, you can do this. There are so many alternatives, right? Now, so far we have seen variables, we have seen arguments, we have seen if commands, and we have tested something. Now, there is also something called functions. So now we have running commands one after the other, but there is also another way to write scripts that makes them more like real computer programs. So functions are using functions. So functions are a set of commands that gets loaded into the memory. So if you have worked with any of the programming languages, you might have seen we use a function, then define the program, and then we call it in the end, right? Or wherever you want to, you call it, right? So it's similar in the bash script too. So they are a set of commands that get loaded into memory when the script is started, and that can be called at any time and in order as long as the script is running. Okay, so they are not they are the most often used with options entered by the user or the menus. You missed the first part of this one. It's still on YouTube, you can see it. So with this we can write scripts using text editor, and it will look something like this. So when we are again using a bash script, so we will do all of this again. I forgot. Okay, and this is an example using functions. So first we will declare a variable. Okay, and we will see a equals to b. We will do simple stuff, right? C equal to d, b equals to c. Okay, I should have put this first. B equals to c, c equals to d. Okay, and now we will write our function. So how we do write function normally, you can just write like that. Function, bracket, and inside it we will load our variables. Oops, too many spaces. First we will load local variables since they are local, equals to 1, and we will declare it as a local variable. And now we will write command to execute. And now we will just do return. So this is a optional command. It will exit right after it executes the command in the function. So like it exits the function and it won't exit the script. So you can use return, and we can close the function. We can write a function 2. If you see, it's just like how we write functions in other programming languages. There is no such rocket science in there. So we can declare another variable equals to 2, equals to 3, or something like that. I said var for that too, right? I can do var 1. Again, we can say comment it as local variable. And we can add commands. And we can also write exit. Okay. Now what we will do is exit. This will exit script with an error. Okay. And we close this. And now execution. And we can use tests. So this is a like normal what you call template which you can use for writing functions in a script, and commands to call functions. And then after all of this, you can just exit, and this will exit script with status 0. Okay, and think we are done with it, and we will use Control X. We will name this file function. Oh, what happened? Oh no, everything is gone. Okay, I will just write one function now quickly. Everything is gone because I did not save it. Oof. Bash equals to B, B equals to C, C equals to D, function 1, local. We close the function. Okay. Now we declare function 2. exit 1, we close this and we write hashtag execute hashtag tests, and then we add exit. Now I'll just copy it since in case I forgot to save it again. Okay, Control X, yes. File name to write gh.sh. Okay, now we saved it. And now we will try to execute. We wrote it as gh.sh, so we will do it. Permission denied. Oh, it wasn't executable, so we have to add permissions for it. We can just do chmod plus x. Now it should be. It didn't do anything. Because it was just a function which we decided to do it, but yeah, if you write some real functions in it, it will execute for sure. And you can also see some functions in your other bash scripts. Nano gs.sh. Okay, now you can see that it's been saved and now it shows the functions in all the colors, and we can show some command. We can write sudo apt update. We can write something else here, and this is how you can write functions. So this is a basic template which we did in this file, and tomorrow we are going to try actually doing all of this in a real project. So today you have learned a lot of things like variables, you have learned arguments, and you have also learned functions, so you can declare functions just like you do in your programming languages, and you can write tests, and you have also learned if else statements, like if there is something present in the system, you execute this command. If there is not, then you execute that. So yeah, so this is the basics for today, and tomorrow we are going to make an project based on like a real project, no templates this time. So we are going to make a real project using bash script. So yeah, these are all the concepts you need to know to get started tomorrow, and I will see you all tomorrow. So yeah, I hope you liked this session. I know there were some mistakes in between, but if you have any questions, then you can ping me up on Discord, or you have my Twitter ID right there written. So, yep, I will see you all next time. Till then, I can put on some tunes for you. Bye, all.